All right, I believe I'm live. Hello, everyone, and welcome to the XState webinar. So, we're going to be doing webinars pretty much monthly, just teaching you the basics of XState and how to get productive as quickly as possible with XState. So, um, I'm going to be watching the comments. So, if you want to comment on YouTube or Discord or otherwise, then please feel free to ask any questions. So, let me go ahead and share my screen and let's just dive right in. So today we are going to be creating a feedback form. And so this feedback form is actually one of the templates now on the, if I go to github.com/statelyai/xstate, uh, you or it might not show over here, but that's okay. So if you go to the GitHub page, there is a templates directory, and in that templates directory, there is a feedback form. And the feedback form is part of the vanilla TS and the React TS templates, and there's going to be a bunch of other templates coming up pretty soon. So before we get started, if you're new to XState, I just want to explain real quick what is XState. So XState is a visual state management and orchestration library. You might have heard of it as a library for state machines and state charts, but it actually goes a lot further than that, and actually even a lot simpler than that, depending on your use case. So if you go to stately.ai/docs, that is where you're going to find our beta documentation. And we're moving from the old XState v4 docs over to these newer docs and adding a ton of new information. If you click Get Started, you should see a whole bunch of information about state machines and everything like that. That's not where we're going to get started today. We're actually going to get started with just learning the XState library and also making some state machines along the way to solve the problem of creating a multi-step form. So XState is a JavaScript/TypeScript library, and you could install it via just yarn add XState. Not sure if you could see it that well. Hopefully you can. Anyway, it's just yarn add XState or npm install XState. So that's what we did over here. In fact, you could check the package.json. We have XState, oops, not that one, but React TS. We have XState installed, and for this, we're also going to be using XState React. But we're not going to start with that. I just want to show you the basis of XState first, and we're going to be using version 4. Now, version 5 is an alpha, and it's right around the corner, but we're not going to be using that for now. Everything you learned, though, today is directly or almost directly applicable to version 5 when that comes out. So again, we're using the latest XState version 4, and we're also going to be using @XState/React, which is the React integration package. But let's get started with, with what we're building today. And also, let me just make sure my dev server is running. Again, please feel free to ask any questions, and I will answer them. All right, so what we're building today is a feedback form. And so the feedback form is in this single app.tsx file. We are using TypeScript. You don't have to use TypeScript, but that's what we're going to be using. And you can see that there's a bunch of forms over here. We have a how was your experience form. Sorry, not a form, but a view. A what can we do better view, and a thanks for your feedback view. And another view that's not shown, but it's just a view that says the feedback form was closed, and it gives you the opportunity to provide more feedback. All right, so let's actually get started with XState itself. So what is it? How do you use it? There's really one or two main functions in order to get up and running with it, and that is createMachine. So what is a machine? A machine in XState is a state machine. So a state machine is a collection of finite states, events, and transitions. Now, you don't necessarily need to model all of your app logic using these states, but as your logic gets more complex, these states could be really helpful. But just to demonstrate that point, we are just going to be creating a simple machine that just holds data. So I'm going to call this const feedback machine. equals createMachine. And this object over here, that is your simplest machine. Let me go ahead and bump up the font size just so that everyone could see. I'm going to move this up to, let's say, 30. All right, that should definitely be big enough. So this machine is a valid machine definition. It's an empty object. It's not very useful as is. So let's actually make it a little bit more useful. I'm going to add some context, and this is where you put all of your data that you want to manipulate in the machine that might not be related to the finite states. So in this case, I actually want to model this feedback that goes in the form. So for now, it's just going to be an empty string. So I'm just going to set it to an empty string. That's great. Let's take a look over here. We could grab the initial state of the machine via feedbackMachine.initialState. So if you're coming from Redux or libraries like that, you're probably familiar with the concept of an initial state. That's a state where when you start the store, or in this case, the machine, this is where the starting point is. It's your initial state. So actually, let's take a look at what's inside the initial state. So we're going to console.log initial state.context. And you could probably guess that, well, it's feedback with an empty string. So we could add more things in there, counts 42. And you could see that, we have counts 42 in that context. So that's sort of useful, but it's not that useful until we have some way to update that. So how do we actually update states? Well, the difference between event-driven libraries like XState, Redux, useState, etc., and other libraries is that you don't directly manipulate state. That's one of the safety benefits of using something like a state machine. So instead, you do things based on events. And so one possible event could be an update event. So let's say on feedback.update. And then you could do things in here. So you could transition to a state, which we're going to show you pretty soon, or you could actually assign a value to context. And to do that, we're going to be using the assign action creator from XState. So actions, going to assign, and we're going to set feedback to updated. So let's actually try this out. If I say const next state equals feedbackMachine.transition, and if you know XState already, this is very basic information. So I'm just showing in case there are newcomers to XState. We have initial state, and let's give it that event. So the event is feedback.update. So now let's console.log, if I could type, XState.context. You're going to see that the feedback is now updated because I sent the event, and the event performs the action of updating that context. But now let's make this a little bit more dynamic. Instead of just type, feedback.updates, we actually want to assign some payload. So let's add a value. This is from the event. So how does that get over to feedback? Well, this can be changed to a function that receives 2 arguments, or it receives more, but for most use cases, it just receives 2 arguments, context and event. So we could just give it event.value. And now when we save this, you could see that this says this is from the event. So we're getting that from the event. Now, the interesting thing about state machines is that if you have some sort of bogus event, it's going to be completely ignored by the state machine. And this seems innocuous, but it's actually a really important concept to grasp because, again, that's one of the safety mechanisms of a state machine, making sure that an event doesn't do some unintended behavior in a state where it doesn't have a transition. All right, so we have our state machine working, or a very, very basic version of this. And we also see that the event is not typed. So let's actually fix that real quick. There is something called schema that you could add, and this will probably be renamed in version 5. But you could just say the events are going to be this shape. So type feedback.update, and the value is a string. So if you're using TypeScript, this is relevant, but if you're not, then don't worry about it. And so now we could see that this event is properly typed to have feedback.update with the value. And so even when we do something like this, type, we will actually get that feedback.update. Ignore the other ones. Again, those will go away in v5, but feedback.update is the one that we want. All right, so to actually make a state machine useful as something that's alive, we need to interpret it. So we're basically turning it from this pure data structure with a pure transition function to something that actually holds states. So this is the same as a Redux store or useState or Pinya view, just wherever you're coming from. And so that's going to be using the interpret function. So this is going to allow us to interpret our state machine and actually make it useful. So actor equals interpret. You pass in the state machine, so feedback machine, and you start it. And now this isn't going to be very useful because we can't exactly log out what's happening over here. But now you could type actor.send. And again, you're going to have that autocomplete value hello. And you could subscribe to changed values via actor.subscribe. Actually, I wonder if this works. State console.log state.context. It works. Oh, okay, so it does. And it showed that we actually got the initial one. Ignore that for now. But when we sent the event, we got also that feedback.hello, or the feedback of hello. So I could say over here, goodbye. And now you could see over here that we are getting that updated context. So that's working pretty well. I'm going to take a look at the comments real quick. Johannes asks, I need to know what this VS Code extension is, or maybe it's just standard functionality. I actually set this up a few minutes before the webinar. It's called Wallaby or Quokka. It's one of the two. Quokka is really useful. I had to get a trial license to make this work. It's unfortunately not free, but it is very useful. So I recommend it. Okay, so now let's actually make this even more useful and make it running in our actual React application. By the way, if you're using something like Vue or Solid or Svelte, etc., then most of this is going to apply the same way. And I'll show you what I mean in a minute, but basically these skills are transferable. You don't need to learn anything framework specific for any of these things. Okay, so I'm going to go to my app, and we see over here that we have a form, and the form has a text area, and we basically want this change to show up, presumably in this thanks for your feedback area over here. So let's make just that simple use case work. I'm going to go all the way up to the top over here, and we are going to import a couple things. First of all, we're going to import useMachine, and this is going to be from our XState React integration package. We're also going to be importing, well, our machine, because otherwise can't really do much. Okay, so how does useMachine work? Well, if you're familiar with useReducer, useMachine is going to work pretty much the exact same way. So whereas with useReducer, you might say const state dispatch equals useReducer, some reducer, and some initial state. With XState and XState React, it's very similar. So const state send, so send instead of dispatch. You could call it dispatch if you want. I'm not the boss of you, unless you work for me, then I am. But we call it send. You could call it dispatch, and useMachine. And so we're going to pass in the feedback machine. And that's it. And the reason that you don't need to pass in an initial state is because that's already determined by the machine. Like the machine definition knows what the initial state is going to be, so you don't have to pass it in manually, which is pretty nice. Otherwise, exactly the same thing or close enough to it. Okay, so now let's actually send some events. So this text area, we're going to go here and we are going to send and that type feedback.update. I get my nice autocomplete over there. And the value is going to be our events target.value. So this is going to send that update events to the machine, and then we are going to receive that in our state. So again, this is going to work pretty much the same way as useReducer. And just to show you, I'm going to log that out over here. So I'm just going to put it right here. And let's see, this is going to, trying to think what this will look like. Maybe just a paragraph. This is going to be state.context.feedback. And we'll even wrap it in quotes. Okay, so so many things can be better right now, especially if you're following the news with SVB, but that's besides the point. So you can see that state is updating. Now, this is all cool. You might be thinking, okay, this is something that I could have done with useState or even useReducer if I'm feeling fancy. Why do I need a full state machine for something like this? Well, the reason is because state machines allow you to do a lot more than just have a state container. And so for our feedback form, we are actually going to design a state machine that takes us through multiple states. And so the first state is going to be just showing this prompt. How was your experience? And if you click good, then, no need for feedback, at least in our example. So we're going to take you directly to thanks for your feedback. If you click bad, then it's going to take you to this form asking you what we could do better. And then you could change your mind. I don't know what would make you change your heart in a feedback form. If you click bad, something probably went bad, but maybe you accidentally clicked it. So you could click back and then click good and then go to thanks for your feedback. And then you could submit the form if you clicked bad, and that will also take you to thanks for your feedback. All right, so I just explained it in a bunch of words, but I think it's a lot easier to see it in a diagram. So I'm going to use the XState VS Code extension, and we're actually going to edit this form and make it work. So we have a very, very simple state machine over here. Let's call this feedback, and apologies if you can't see it that well. Ooh, that's a lot. Okay, so we have our feedback form, and we are going to, let's not add a new state just yet. Or actually, yeah, let's add a new state. So in our feedback form, we're going to have a prompt. And on the prompt, we're going to go to our form. So I could just click the plus sign there. And this is if feedback.bad. So now this takes us to our form. And then let's go down here. Shift this a little. When we submit the form, this is going to be our thanks screen. And then we also have this closed state. And yeah, I think this looks right. Oh yeah, forgot that we do need to add if we have feedback.good. It's going to take us directly to our thanks screen. What am I missing? Oh yeah, we could go back. So I'm just going to have an arrow going back like this. And oh yeah, we also have this feedback.update, which right now it's actually over here, but I want it to be part of the form. So let me just drag these right over here, make that look a little nicer. Or maybe I could just right click in auto layouts like that. We have closed over here. Okay, so trying to think, when you submit, it goes to thanks. Oh yeah, so when you have it closed, you could restart it as well. And so that will just take you to the prompt. Again, it's just for this example, doesn't necessarily need to be this exact flow. Now, in the editor, you're actually going to see this orange question mark over here that shows that this is an unreachable state, which is true. There's no way to actually get to that state. And interestingly enough, this is not something that's easy to pick up in code. Whether you're writing a state machine or not, uh, that you're not going to have any sort of clue that tells you, hey, you can't actually reach the state. So you sort of need to, or actually, it's pretty nice that you have an extension or an editor in this case that tells you like, hey, this state needs some way to get to it. Otherwise, you could just straight up delete it. So let's actually add a transition that goes directly here. Move this over here. And this is interesting because the fact that this close event is coming from the top, it means that from any states within this state, and we're going to get into nested states in a minute, but from any state within this feedback top level state, you could go to the closed state. So if I click simulate over here, it doesn't matter which state I'm in, like form, I could go to closed. Then I could restart, bad, submit, I could close it, etc. So that's why it's useful to do that, because the alternative to that is having basically an event on every single state to go to close, which is not something you want to do. It doesn't really feel too good. So instead, we're going to have one coming directly from the parent state. All right. So again, let's go over the flow of this form. Initially, we're in the prompt state. And when you click feedback.good, it takes you to thanks. And then, of course, you could close it, close a form. You could restart it. Now, if you enter feedback.bad, it's going to take you to the form, and you could update the form and submit it. And then it takes you to the thanks state, closed. And of course, you could also go back and change your answer. Funny enough, you can't change it once you said good. It's just like, all right, we accept that your feedback is good. Okay, so what's awesome about the VS Code extension is that what we just diagrammed actually shows up in the code. So we have our entire state machine pretty much coded out. And it's almost exactly the way that we would have coded it, with one exception, this big layout string over here. This layout string is really only useful if you want to share this layout, in the visual editor. It could be source controlled, but it's not really meant to be human readable. It's just showing you the position, or it's encoding the position of all the states. So you might want that, you might not want that. Up to you. It's harmless if you want to delete it. So there is that. So yeah, let's continue on. And again, if there's any questions, please feel free to ask in the chat. I am reading it. Okay, so now that we have our feedback machine and we verified that the flow is what we want it to be, let's go back to our app and actually make things show one step at a time. Okay, so the first step that we are going to do is we are going to show this, actually we're going to show this close button pretty much all the time. But we only want to show the prompt step, which is this one over here. How was your experience? If the state matches that step value that we have. So state.matches step. And yeah, okay. That. Okay, so obviously the state's not matching step. So let's take a look over here. And that's because our initial state is prompt. So we should change that. In fact, I could open the visual editor. Unless it's frozen. Okay, maybe I won't. Let's go to step. Okay, so our initial state should be step. And so now when I reload, have a slight error. Let me check what this is. Oh, I prompt. I don't know why I called it step. Okay, so if I reload this, it's going to show what can we do better, and thanks for your feedback. And of course, it should be prompts. I'm having Friday brain. I looked at step and I'm like, oh yeah, the state is called step. No, it's called prompt. Okay, so now we're showing this, but of course we want to hide the others if we're not in the appropriate states for them. So state.matches form. And then I'm going to just cordon that off. And then this one is state.matches thanks and if class name step. Okay, awesome. So now what we have is we have each panel or each view showing for the appropriate states. So if I were to change, for example, the initial states to form, and by the way, this is a nice little testing trick. Because you're using a state machine, you could just change what the initial state is and reload, and you could see each state as the form changes. So if I want to see the thanks view, I could just change initial to thanks, and then I could see it. If I look at closed, nothing shows up, and that's because we should add this over here. So if state.matches closed, okay, so let's take a look at that view. We have feedback form closed, and we could click here to provide more feedback, which is not going to do anything right now because we have to actually add that functionality in there. Okay, awesome. So taking a look at the questions real quick. Johannes says, would be great if the VS Code extension hit that layout string. I completely agree. And we're thinking about ways, there are a couple ways in which we could tackle that problem. The first is, as you mentioned, just having VS Code auto hide that or collapse that or something like that. And another thing that we're thinking of is just having more of an integrated, like a whatever you call it, a config file or something like that, where the data related to the layout actually lives somewhere else, not directly on the machine. And that might make it easier to read. Let's see. Gavin. Hey, Gavin. Gavin says, my eyes have pretty much adjusted to ignoring it at this point, but I'll take that as feedback for the team. Again, if you're not using word wrap, it shows as one line, but I use word wrap because I don't like scrolling left to right. So yeah. Diver says, could we have an example where a button is disabled based on the guard? Yes, that's coming up right after I talk about transitions. And yeah, Johanna said sidecar file. Completely agree. I think that this idea, because we already have that for type gen, that idea for other layout information and soon colors and other descriptions and things like that, that's going to come in really handy. So yeah, let's definitely talk, about a config file. By the way, Gavin is one of our awesome engineers at Stately. We only have awesome engineers, so he's one of our engineers who is awesome. Yeah, hi Gavin. Anyway, okay, so we've talked about the different states, and so let's get back to our initial state. So initial is going to be prompt. So when we reload, we see that this is working. These buttons are not working. That's not a bug. That's just something that we didn't add in yet. So let's go ahead and add those in. All right, so on click, we are going to send. We're going to send an event object, and I do want you to get used to the habit of sending event objects just because that's going to be the way going forward in XState version 5. And it makes things a lot more consistent, so I recommend you do that. And actually, before I do that, just to make things a little nicer, again, you don't need to do this, but I'm going to just add all of these event types over here, feedback.bad. We also have type submit and type back and type close. Cool. So we have all of our events here, and I believe all of our red squigglies, except for this one, is gone. So let's add that one back. Type restart. And by the way, if this is tedious, I completely agree with you, which is why when you're editing and creating state machines in stately.ai/editor, you have the option to export to TypeScript, and you already get all of this typed out for you. No need to type it out. So it's pretty nice if you want to do that, but we're doing things manually because that's the best way to learn XState. Okay, so let's send, now that I have my nice autocomplete, feedback.good. When I click good, and over here, I'm going to send type feedback.add. Also, I wonder why Copilot's not working, but that's okay. We don't need Copilot for now. We're going to be doing things the manual way. Okay, so let's test this out. When I click good, it says, thanks for your feedback. Great. When I click bad, it takes us to the form. Also great. So we know that that's working. Let's just do everything else now. So let's submit over here. So this is going to be send type, submit. And yeah, this is where we're going to be adding that guard logic. And this is going to be, oops, send type back. And then I believe that there's one more that we have to add, which is right over here. Send type close. Now, one really interesting observation from all of this is that everything in this view is basically doing two things. It's reading state or it's sending an event. And that's pretty much it. So what this means is that the majority of your logic lives inside of this machine. So if you want to take this to view, if you're writing some, I don't know, Blazor template, or you're doing things in PHP and you want to reuse this definition, it becomes possible to do so, or at least to reference it, because it all lives inside this big, machine object. Why is this on close? There we go. So yeah, your views essentially just become this this shell for your actual logic, which just separates concerns really, really nicely, at least in my opinion. And in terms of maintenance, it makes things just a lot easier. Okay, so let's test all of this logic. I could click good, close, provide more feedback, which does nothing. So let's, we missed one. So send, oops, send type, restart. Okay, so good, close, provide more feedback, bad. Hide the darn layout string. I could submit that, and now it shows hide the darn layout string. I could close this, and also I could close it at any time. So even if I'm filling out the form, I could close it out of rage, except that's not working. So I have to figure out why that's not working. Oh, wait, it is working. How'd that happen? Anyway, okay, so everything's working. Now, someone in the chat asked about this. Could we have an example where a button is disabled based on a guard? And I love this because this is something that XState allows you to do a lot easier than other things. Because typically when we're writing app logic, for example, let's say that we want to disable this button if there is no feedback. Like obviously, if you're on this form, you expect the user to write some sort of feedback. We could do the naive approach of, just tracking, the value of this text area, which already lives in the machine. So we have to grab it from the machine, checking the length over there. And if the length is 0, after we trim it, of course, if the length is 0, then it should be disabled. But that means that you're sort of duplicating that app logic between the machine, when we add the guard, of course, and the actual view. So you could do that. Nothing is stopping you from doing that, but I want to show you a little bit of an easier way. In feedback.update, we are updating the feedback, of course, and that's assigning the value from that event, so this update over here, to context.feedback. Now, we have submit. On this submit event, we go directly to thanks. So let's say that we actually want to prevent this from happening. Well, we could do this. By the way, I forgot to explain this earlier, but to transition to a state on an event, it's on the event type. And as a shorthand, if you're not doing any actions or anything like that, you could just put the key of that state. So in this case, form. If you click good, it takes you to thanks. But this is shorthand for, not type, for target form. And I actually recommend that you use the full object format, even though it's a little bit more typing. You could definitely prototype by just adding strings at first, but the object gives you a lot more flexibility to add things like what I'm about to show you. In this case, we only want to go to thanks on a certain condition. So I'm going to put cond over here. In v5, by the way, this is called guard because this is a guarded transition, but otherwise it's the same thing. And we get a function that gives you the context and the event, but in this case, we only need the context, and we want to see that the context.feedback, let's trim it, .length is greater than 0. So what this means is that this condition is going to be checked first. If it's true, then we proceed with going to target and maybe executing some actions if we have any actions. But we don't in this case, so we're just going to go to target. If this is false, then this transition is known as disabled. It's not an enabled transition, so it's not going to be chosen, in the state machine. So it's as if, nothing is happening. And so if you wanted to, you could put this in an array and say, if this condition fails, then go to some error state or whatever you want. We're not going to be doing that here, but I'm just mentioning that as, as a way to basically branch out. Depending on some condition, this transition could go to different targets. Okay. So now let's see what happens. I'm not going to disable it yet just because I want to show you the default behavior and why state machines are awesome, even if you're missing that disabling. So let's say I go to bad and I type a bunch of spaces because, again, we have trim in there, and I click submit. It's not broken. The logic is actually correct. You shouldn't be able to go submit anything unless you have something here. So if I click submit, now it will take you to thanks for your feedback with that feedback in there. But while this is good and it prevents you from forgetting to disable buttons, it's better to show the user some visual indication that they're not allowed to move on. And so the way that you could do that is by using this fun thing, as Johannes mentioned, can. And so this is really great. Instead of thinking this button should be disabled if when we trim this context.feedback, the length is 0, like that's confusing. What's better is if you think this button should be disabled if clicking it will do nothing. So basically, if we can't transition on this event. And so that's just state.can. And we give it the event. So submit. What this is going to do is it's going to evaluate this event on the state machine. And if that event, if that transition, if state.can evaluates and says, oh yeah, you can transition if you send the event, then everything is good. State.can will return true. Otherwise, it's going to return false. So basically, this reads like plain language. If we cannot submit. So if not, state.can submit. Can't get any simpler. I mean, you could do this, but again, we're getting in the habit of doing this. So, yeah. Okay, so let's see how this looks. If I click bad, now you can see it's actually disabled until we type something. So I could erase all this, even if I add a few spaces, because again, it's evaluating that guard. So I could type hello, and now it shows hello. So that's thanks, Michael. So that's a really, really cool tool to have in your tool belt, which is state.can. All right, just looking over here. Johanna says you should see my discriminated union ZOD definitions for my events. I'd love to see that. ZOD is a very useful runtime/compile time type checking library. I don't know how exactly to describe it, except that it's very, very useful for types and types that work both in the runtime and during TypeScript time, type checking time. Yeah, so let's actually extend this a little bit because we have a little bit of time. I'm surprised we got through all of that in this amount of time. It's pretty great. In fact, I'll open the visual editor so that you could see the state of our state machine. If I zoom in here, again, we have all of our same logic right over here. And we even have, if you could see here. Wow, this is big. If, and then inline. Inline doesn't really read that nicely, but it's necessary right now because right now we can't really serialize this condition in a way that the editor can understand. So one way that we could, sort of just make this nicer for the editor and also nicer for reusability is to just give it a string. So can submit. And then where do we define this can submit? Well, that's the second argument to createMachine. So in guards, we type can submit, and then we have that over here. So now we could reference that can submit in any cond property. Again, in v5, it's guard. And now in the editor, you see a nice little if can submit. In fact, you could do the same thing for feedback.update. So instead of this inline assign, this is optional, by the way. Only if you want to like just organize your state machine a little better, you could move it to these serialized, or whatever you want to call it, serialized actions. So I'm going to just call this actions update feedback, and I'm going to add it over here. So actions update feedback, and I'm going to just put that there. We do have to sort of massage the types a little bit here because when you put an action over here, it means that it could be called with any event. So, yeah, but you could just do this. If event.type is, feedback.update, return event.value. And so this is sort of a safe way to do it. Otherwise, return context.feedback. A little bit verbose. But if you're using typegen, typegen actually helps you here because typegen knows that update feedback is only being called in this place with a certain subset of events. So you don't need to do all of this. But if you want type safety, like super type safety, you could do this. Yeah. So just an option. But anyway, now our state chart looks a little bit nicer because we say that when we're in form, and the feedback.update event happens, we perform this update feedback action. And when we click submit, we know that only if we can submit will we transition to this state. So because we serialized our actions and our guards, this reads actually a lot nicer. And the functionality, of course, is still going to be the same. At least I hope so. Bad. Typing stuff, and then thanks for your feedback, close, and now we could provide more feedback. All right, so just looking at the questions real quick. Is the form state being reset on submission or closing the modal? Good question. Let's find out. Because if it's not, then it's not a bug. It's just something we forgot to do. So provide more feedback. Bad. It looks like it is. And so I think right now the reason that it is because, yeah, why is that? Because, it's because this text area is an uncontrolled component. So if we do want to make it controlled, and this is more of a React specific thing, but we could say state.context.feedback. On autocomplete. It's not playing really nice with me right now. But yeah, so now your fantastic bug is going to show up because it's going to still show that FAWEF, all of that good stuff. So there's there's actually many ways that we could address that. And so that's with an entry action. We talked about transition actions over here. Actually, do we? Yeah. So over here we have actions update feedback, but now we could say that whenever we enter the closed state from any transition, we could assign that feedback to an empty string. And so essentially we're resetting the form in that way. Again, this depends on your app logic. Let's say that you have a universal back button and you go back to the form state, even though you've submitted it already, you might want to see what your previous response is. So you might not want to reset the feedback to an empty string every single time. So now if I reload this, click bad, blah, submit, close, provide more feedback, bad. Now you can see that it's gone. And it's gone because when we entered the closed state, we emptied out the feedback. So I'm just going to call this reset feedback. And I'm going to put that right over here, reset feedback. Okay, so now if we take a look at the actual state machine, we could see what's happening over here. So in the closed state, we reset the feedback. And for those who can't see, just shows right over there. All right, so Diver says the shorthand can submit looks better for conditions inside components. So what's also great about doing it with an object, which we have over here, so state.can type submit, is if you have payload, like some payload, then the state transition will be checked against that payload. So it's going to actually evaluate all of the guards and see, or not all of the guards, but only the ones for the current state, and see, can the transition actually happen? So that's why, again, getting in the habit of sending an object instead of a string could actually be useful. And yeah, Johannes, and so instead of parameterized, serialized, they're basically named. I think that's a better way of calling all of those things. And yes, as he points out, form inputs are external state unless you make it fully controlled using value, which is not necessary. I like using uncontrolled components unless I need to show the value somewhere else at the same time or other things like that, but it's really up to you. Okay, so if there are no further questions, let's do one more really fun thing with this state machine. It's a bit unrealistic that right now, when you submit the form, so actually I'll do this over here, it goes directly to thanks. You might be wondering as a user, is my submission actually going to go anywhere? So we want to show the user like, hey, we're actually sending it somewhere. I don't have an API set up for this, so we're just going to fake this using a timer. And it's a really good learning opportunity for learning what timers are too. So I'm going to go to the submitting state, and then I'm going to put an after event. Right now it says after 500 milliseconds, but we could change that to, let's say, 2 seconds. Why not? Okay, so after 2 seconds, we are going to go to the thanks state. And this is just to simulate it. I'm going to show you invocations in a minute, but let's just take a look at this. And yeah, so you could see our state machine has updated. We now have target submitting. And after 2 seconds, it's going to go to the thanks state. So let's see how this looks. I'm going to close this, reload this. Good. Oh, obviously we didn't submit any feedback. So wait 2 seconds, submit. Okay. So we obviously need some sort of panel or something for that. But actually there's something else we could do just to make this a really, really fun example. Instead of considering that submitting part a separate state, you might think like, hey, this is actually part of the form, like, because we should still be on the form state. So instead, I'm going to reparent this, and I'm going to put it under feedback.form. And of course, that state doesn't exist. So let's see. We're in submitting. After 2 seconds, it goes to thanks. And let's see, child state closed doesn't exist on feedback.form. Well, I know that, but I'm wondering why it's, okay. Sorry, I'm going to close and reopen this because Friday Brain is just not working with me. All right, well, let's do it in code for now. All right, so we're working with nested state. Oh, okay, I know why. It's because I don't think I added an initial state. All right, so we have states submitting, but we also want states, and let's just call this editing because you're editing the form. And so now what we could do is move all of these not back. That should happen in any state, but the submit and the feedback update should go inside of this on over here. And so on submits, we go to the submitting state, and on feedback.update, nothing should happen except updating the feedback, of course. So let's see if this actually works or if we get an error. Just double checking over here. I think I moved things around a little bit too much. So child state closed. Yeah. On closed. Yeah. Okay. That was the issue. Not sure why the editor. Oh, you know what? It's probably because I moved the wrong states into the parent state. I was trying to be adventurous. I apologize for that. So now let's open the visual editor and see what we have. Maybe do some auto layout to make it a little bit nicer. Okay, so we see that in the form state, now we have two nested states. And just to illustrate what's going to be, what the logic is over here, when you click feedback.bad, I see a bug. So, or not a bug, just a logical fallacy. We go directly to submitting, but instead we should actually go directly to editing. So let's try that again. Click feedback.bad. We're editing the form. And if we could submit the form, then we go to this submitting state. And after 2 seconds, we transition to thanks. Okay, so let's see if that actually works. I'm going to reload this, submit some feedback, submit, and you're going to notice that we are still in the form state. And the reason that that works is because state.matches form is still true. And so this is why it's actually better to do state.matches form than state.value is form, because in this case, the value actually changed to something else. It changed to form submitting. But we're still in the form parent state. So that's why using matches allows you to say, are we in the form states, which we are, even though we're also in that nested child state. So yeah, that seems to be working. It would be nice if we had some sort of loader or something. So let me actually add that real quick. Let's see, what can we do? Submit. Oh, okay. So let's just do this. State.matches form submitting. So if it's submitting, we want to show submitting. Otherwise, we just want to show submit. I'm going to save that, reload, blah. So I'm going to press submit. It shows submitting. And then after 2 seconds, it goes to thanks for your feedback. All right, so let me answer some questions real quick. Let's see. David just loves curly brackets. I really, really do not. And honestly, that's one of the reasons why we have the visual editor, so you don't have to deal with all those curly brackets. You could write state machine definitions in YAML, but I know that some people get heartburn when they work with YAML too. Yeah, it's just a few of the options. Side effects are dirty. Keep the code pure, of course. How do you merge your machine exported from Stately with your local actions, guards, context schema, etc.? So we actually demonstrated that here, where my actions and my guards are intact. And even though I edited in the editor, these were untouched and everything else just worked. So it does that pretty clearly. Small bug. I think feedback bad, enter text bad, feedback back. Feedback bad, submit button is active or not. So let's see if I reload this, bad, that, back, bad. Oh, the logic works out pretty well. And Gavin says, at the end of the day, we export JavaScript, TypeScript, JSON, context and schema included. What I prefer to do, though, is just name my actions and implement them locally. And yeah, this is part of our like future proofing future plans, where eventually when we want to support different languages, you might just want the JSON representation of the machine, and you might want a text representation of implementation details like actions, guards, delays, invocations, things like that, where you could just say, listen, I'll implement it later. I will do it in my own language. I don't need to shove that into JSON. And that's perfectly fine, because the editor then becomes just this blueprint editing tool for all of your logical flows. Bastion says, with the controlled input, it works out, but without it, it would have shown an empty input, even though the internal state is still set, I suppose. Yeah. So you're right that the submit button will be enabled if you had an uncontrolled input, and it will show as empty, even though submit is is enabled. And you might think, like, is that a bug? Yeah, so that's why, in this case, having a controlled input might actually be the right solution. So again, that's up to you. So we're coming up on 3 minutes to the hour. So I just want to show you one more thing. And this is more of an advanced, but very, very useful and not that difficult concept in XState, which is invocations. Invocations are really useful because this is the orchestration part of XState being a visual state management and orchestration library, in that you could actually just invoke other things to do things and bring you back information or communicate with it. It's really, really powerful. So right now in submitting, we have this 2-second delay where it just goes to thanks. But let's say that you actually want to send that somewhere. You want to make an API call, invoke some endpoints. So let's actually do that. The way that we do that, at least in version 4, version 5 is similar, but in version 4, we have this invoke property, which is an object that you could pass it a few things. You could give it a source, and that source, again in version 4, it takes context and event, and then you could invoke a few different things. You can invoke promises, observables, other machines, or callbacks, or reducers, I believe, too. And in version 5, this is going to be much, much more flexible, and the syntax is going to be very, very similar. So we are, in this case, going to invoke a promise because that's pretty much the simplest thing to do. And so we're going to just, I guess, do new promise, solve, and let's just make a set timeout. This is also going to be after 2 seconds, or let's make it faster, 1 second. And we're just going to resolve, I don't know, status 200, just whatever information you want. Just pretend that this does something, hits an endpoint, or whatever you want it to do. So instead of after, I am just going to make this onDone. So onDone. And just like the other transitions, we could give it a target. And in this case, it's going to be feedback.thanks. Okay, so now let's try this and see if it actually shows that. Again, this is going to be a little faster because we're doing it in 1 second. Submit. There we go. Thanks for your feedback. So now let's actually see what happens if that fails. So we have to make some sort of error state. And now let's actually do something if there was an error. So I will just put that. Let me just see what the UI looks like. I'll just put it after the button. So we're just going to do state.matches form error. Is that what I call it? Yeah, error. And I'm going to just get a little paragraph with style color red and say your feedback was not heard for whatever reason. I don't know. All right, so let's actually make this fail. We are going to now reject this. And status 410, I don't know, gone. Let's reload this, bad. Oops, click the wrong one. Submit after 1 second. Oh, I did not add the onError. That would be necessary. So target error, Reload this. Bad. Okay, so now it shows the error, which is really, really useful. Um, so yeah, and then, of course, we could just try again. We could say on submit and then just allow that behavior again. So if I reload this, submit, it's going to give me an error. I could try submitting again, gives me an error. And in fact, you could do things like, I don't know, just setting a maximum count of like how many times you could retry. There's a lot of things you could do. So now let's take a look at, and actually to make this work, let's just do math.random is less than 0.2, then we reject. Otherwise, we're going to resolve with something. Doesn't really matter. So hopefully it actually works this time, unless my luck is bad. And my luck is bad, or I forgot to reload. So let's try this again. Submit. Cool. All right, so now we have our feedback. Everything is working fine. And now let's take a look at our state machine and clean up just one more thing. And then I will let you go on with your Fridays and your awesome weekend plans. So I'm going to clean this machine up a little bit by doing auto layout, except where did my auto layout go? Oh, that's right. I'm not in edit. There we go. Okay, so now I have a bunch of things happening over here in editing. That's where I start, submit, submitting, error. But there's a weird arrow over here. And that's this right here. It's going from this inner child state all the way to thanks. And there's a cleaner way to approach this. We could have submitted, and we could have, oops, back to content. We could have this as a final state. And you could tell it's a final state by the way it is, or by this double boxed thingy. In traditional state machines, it's just a double border, but that looks too confusing with all these lines going everywhere. So that's why we opted for an icon. And so now instead of this done being over here, let's actually zoom out a little bit and move this to this submitted over here. And now we could create a transition from this state to thanks when the state is done. So now we don't have to be concerned with the inner workings of this logic. We just say, hey, form, whatever you're doing in here, just whenever you're done, take us to the thanks state. Okay, so now the logic should actually be the same. So if I submit, unless I get an error, wow, just unlucky today. There we go. Then it takes you to thanks for your feedback. And yeah, so we learned a bunch of things today. We learned how to use a state machine just as a simple state container using context and state machine level actions. We learned about state transitions, so going from states to other states. We learned about guarded transitions, so the ability to specify a guard and also having named guards and actions. And of course, we also learned about actions and transitions that stay in the same state and only perform an action. We learned about invocations and onDone, onError, and how you could invoke a promise. Again, there are so many other things that you can invoke. We learned about, again, guarded transitions. So we could say only go to this state when this condition is true. And we learned about nested states and states being done. We learned about a bunch of stuff, and we were able to visualize a bunch of things. So now we could see that we could just click simulate and understand our app logic by walking through it. So we could say, oh, if I click feedback good, what happens? It takes me to the thanks screen. Or I could say if feedback is bad, I could submit it. And then when it's done, it takes me to the thanks screen. And of course, I could close it at any time and restart at any time. So just taking a look at the comments. Gavin says, I don't have weekend plans. Johanna says, ain't no party like an XState party. Totally agree. Socialist type party on. Okay. It's getting fun. Well, that's Friday webinars for you. Anyway, if you want more information, you could find us at, well, first of all, you could play around with the Stately editor at stately.ai/editor, completely free to use, by the way. More information about us is at stately.ai. You're probably watching this on YouTube, and we have a YouTube channel, youtube.com/statelyai. If you're not following us on Twitter, then please follow us, twitter.com/statelyai. Check out our newest docs at stately.ai/docs, which includes documentation for both the editor, the studio, and XState. And overall, this has been the XState webinar. So thank you so much for joining me. And only me. No one else is here. All right. Thanks, everyone.